In this video, we're going to talk about repeated measures analysis of variance, specifically one-way repeated measures. We're going to use the general linear model in SPSS, the repeated measures option. And we're going to look at axial length over time. Now, we're just doing one way, so we need to split our file by lens type. We're just going to do the spherical versus aspherical, and we need to split by I. So we'll have 6 groups, and we're just going to do an analysis of year for each one. We're going to look at axial length at baseline, 1 year, 2 years, 3, 4, and 5. Now, the thing to notice here is that our axial length is laid out, repeated measure is laid out horizontally. That is, each of the years are on a single row. We have to split by I because in this layout you can't do a repeated measures. You can't, even though I is repeated, you can't use it in this layout. If we were going to do a repeated measures with this particular format of SPSS, we would have AL 1 through 5 for the left eye and AL 1 through 5 for the right eye. We'd have 12 columns across to represent those two. Because I is vertical, we have to split the file. We can't do it. In future videos, we'll talk about how we would do an analysis if our layout is vertical. But for the analysis of general linear models, repeated measures, we use it vertical or horizontal. And the first thing we do is there are 6 years, and so we're going to go into 6. We're going to call that year. We'll add that variable. So we put in our within subject factors on this first screen. We go down to define it, and then we put them all in here. Now, in a later video, we're going to add between subjects, and that's a mixed model. But for now, we're just going to talk about this laid out one. Our options, year, compare main effects. We're going to look at our descriptive statistics. I don't think we're going to look at anything else right now. And one thing I do want to do is do the Bonferroni correction. Now, we're going to talk about sphericity and some of the assumptions done in the overall F test, but the post hoc tests use, in SPSS, they use an uncorrected score, and the Bonferroni kind of is a conservative test that essentially semi-adjusts for the problem of sphericity. Okay, let's see what we get. So we have our variables, AL 0 through 6. They're labeled. Oh, they're labeled here. Okay. We get the N for each one. We have something called a multivariate test. Now, we've talked about y equals a plus bc. In this case, it's y 1 through 6 equals a. There's no independent variable, just an intercept, but there are 6 dependent variables. Kind of a different way of looking at things. We're not going to talk about it any more than that. Then there is this concept of Modulus test of sphericity. And the notion of this is that the assumption of the between subjects, the regular analysis of variance, is that the variances are equal. That's homogeneity of variance. We've seen how we've used Levene's test to check for that. In this case, the items are correlated. So each person is in there, and year 1 and 0 and 1 are correlated with each other. They're not independent. So one of the things that sphericity, the assumption of sphericity, is that the correlations are all the same. And if they're not, then we have to make a correction. And we're going to see those corrections. They're going to be the greenhouse geyser, the Hunt-Felt, or various corrections for this problem. We see the null hypothesis is that everything is equal. We see that we reject that with a small p. Now let's just take a minute and look and try and understand the concept of sphericity. So I have copied down from the database, let's see, SPSS, the AL 0 through 5 years. So we have 26, 27, 12. No, they're not in the same order. Well, anyway, I have copied down all the raw data. Now, sphericity is basically looks at the differences. And so we have axial length 1 minus axial length 0. And it looks at all those differences for each, calculates for each one, and then calculates the variance for that column. It does the same thing for AL2. Over here we have variance just for AL1. Notice that this is AL0. The variance is 81, whereas the difference is a lot smaller. And that's because they're related to each other. So when AL1 is subtracted from, or baseline is subtracted from 1, they're kind of close to each other, so you get a small number, as opposed to when you're going between subjects to figure out the variances here. So you get these differences, and you get the difference between people on the differences. That variance is a lot smaller. We have AL1 minus baseline, AL second year minus baseline, third year, fourth year, fifth year, and then the second year minus the first year, third year minus the first year, and so on all the way out to the fifth year minus the fourth year. And under each one, we calculate the variance. Now, sphericity says that all these variances are equal. And to the extent that they're not, or the extent that they're correlated, really, it's not that they're not equal. The extent that they are that they are smaller, basically, than the variance means that we need to adjust. They're not, we don't have independence, but the assumption of the sphericity is that they are all equal, and those are pretty close. I mean, they look sort of similar if you go across. They're all little numbers. They're kind of equal, but they're definitely correlated, and there's a big adjustment that has to be made to take into account that the variances between the years are not equal, are correlated. I've been saying that they're not equal. That's not the point. The point is that the assumption of sphericity is that the variances are equal, but the correction factor is based on the amount of correlation between the differences, the differences of the individual year comparisons relative to what it would look like if they really were independent. So the this lack of independence is what is being corrected for. All right. So we had our sphericity, and then the greenhouse geyser and the Hunfeld are just two ways of adjusting for no sphericity. Now, sphericity assumed is is a state that the post hoc tests. So the post hoc tests are going to use that sphericity assumed, and we don't want to do that. So we're going to use the Bonferroni correction as kind of a way of adjusting for that lack of independence when we get down to there. But you can see that this is year, and year has 4 p-values, but really we're only considering 1 p-value. And if you were writing up your paper, you would say, we tested the effect of year. The greenhouse geyser has an f-test, a corrected year variable. The f-test is 91.3 with a p-value p less than 0.001. Now here they have tested within subjects contrast. That is, do the years go straight up? Are they a straight line increase? Well, they do seem to go up. And actually, we have a picture of that. This is lens type, and this might be collapsed across everybody. This is lens type spherical, and this is aspherical. So we have the trend is generally going up. That's a linear trend. And if we look, there's this is spherical lens, left eye, aspherical lens, left eye. Spherical lens, we have a linear and a quadratic. A quadratic means there's a bend. In aspheric, we have a significant linear and a non-significant quadratic. That means no bend. What does that mean in our graph? We look at it, the aspheric is just straight up. The spheric has this little bend here as it's starting to flatten off as the years grow up. But aspheric is pretty much a straight out bend there. Really the only other thing that we have here, tested between subjects effects, there's just the intercept. Remember we said that the between subject before, we had between subjects and the value was in here, like lens type was up here. And we had within subjects was the error term. Well, here the error term is partitioned by year. So it's a little bit different. The thing we're interested in is within the subjects. So that's the variance is partitioned within subjects, and in this particular case, there's nothing between. Then we have the estimates. Those were the means we took to plot that graph, and we have the pairwise comparisons. And it's a Bonferroni correction, so all these p-values are with considering that. And it takes into account the difference year 1, which is really baseline, with 2, which is the first year. And we go down here. Remember, rather than 0 through 5, it's labeled 1 through 6, and SPSS tells you what those labels are up here. 1 is 0, 2 is AL1, 3, and and so forth. So that's repeated measures. Try it out. See what you think.